Alright, so Chapter 11 again, the inheritance and polymorphisms. Now we know that we can inherit a subclass from a superclass by using the keyword extends, like this. So circle extends geometric object. So circle is a subclass and geometric object is a superclass. After that, you can add the new properties and the new methods to the class. You can also override the method of the superclass. Like for example, print circle is the method of the circle. We want to print circle is created with the super do use for calling the method of the superclass. You can do super dot get date created, right, and the radius is. Now circle extends from geometric objects, so we can also do override the toString method of the geometric object. So this is another way to showing the override here. And it's going to return the super.toString, which is the toString version of the super, and also returns concatenated with the circles version, which has the radius. Just like this one, return a get date created and concatenate with the radius. So an instant method can be overridden only if it is accessible. A private method cannot be overridden. Because it's not accessible outside its own class, we know that private you cannot override. If a method defined in a subclass is private in its superclass, the two methods are completely unrelated. Like an instant method, a static method can be inherited. However, a static method cannot be overridden. Static method you can inherit, but you cannot override the static method. If a static method defined in a superclass is redefined in a subclass, the method defined in the subclass is hidden. So let's compare overriding with overloading. So overriding is the method that has the same name, like we create a class named A, which has the method P, and with the same signature I, and class B has method P I. Now A extends from B. This is called overriding because same method name and same signatures. So the same method name which extends from B, in B has the method name P. This is called overriding. Whenever you invoke the method in the main, a.p, it's going to call the method that you override and print out 10 if you pass 10. Not going to multiply by 2. How about overloading? Overloading is different in terms of signatures. Even the method name is the same, but the signature is different. In this case, when we call a.p and you pass an int, it's going to get the int version of p in method in class A, which print 10. But if you do a.p and pass in double, it's going to get the double version from class B and it's going to print out 20. the object class and its method. Every class in Java is descended from the object class. That's what I told you, right? So if no inheritance is specified when a class is defined, the superclass of the class is object, right? You don't have to do extends object. It's equivalent to extends objects. Alright, so let's test the concept here. Like circle, if I do like that one, it's just like extends object. If I do extends object, it's pretty much the same thing, right? And also let's test this one, the overriding and overloading. So I'm going to modify. We know that I'm going to create a class named test. And this is the code for that, right? So we're going to have method P and class B and A, right? So let's do that. New class A and new class B. And I'm going to show you how to inheritance, right? Extends from A. So now we're going to write actually try to do the other way around on the example. So we try to write the method in B and A extends B. And this method name is P. And we pass in double I. And what it's going to do is going to just do system.out.print I times 2. Now we're going to create class A, which is going to extends from B, which is inheritance, right? And now we're going to override the method P. Override means exactly the same signature, which is double I. But we're going to re-implementing just printing I, not multiplying by 2. Alright, so we done overriding. Sometimes we like to use a notation override to make sure that our intention is overriding the method override of class B. And we can omit that, but it's a good idea to put it in it, because if you don't put it in and if you happen to mistype like PI like that, it's still not overriding. And you may thought it is. So if you put that, it's going to verify that you have to override. So just make sure we did override. So good to have that. Now we're going to test this by instantiate the object in main, right? So we're going to have the main public static void main string args. So let's test A, right? A equals to new A, and A dot we're going to call P and pass 10. So we expect that it should call the method of A, not B, right? From A, even it's integer or double, like that. So in that case, from A, P is going to print 10 out. So you expect to see both of them showing 10s, which is the concept of overriding. because it's changed the implementation of b to just print I, no, multiplied by 2. That's why it's going to get 10s out. Now, if we want to do overloading, it's just different. We just change double to I. Right. Okay. I have to run the test. But I have to fix this. So I happen to use the old project, so don't worry about that one. Alright, so let's run the test main again. Alright, so as we expected, alright, right, 10 and 10 out. Now, if we do overloading means we're not going to overwrite. Remove the word overwrite out. And overloading is just changing the signatures to different type. So this is overloading now. Method has the same name with different signatures. So let's test now. In this case, it returns 10 and 20. Because 10 is the version of the int and 20 is the version of the double, which is from extends parents method p. So that's the difference. toString. toString is the method in object class, and toString method return a string representation of the object, and the default implementation return a string consisting of a class name. Like, and you run toString without implementing toString, you get the output from the default toString for object. It's return the class name, of which the object is an instance, and @ sign and number representing this object. So that now be what you're going to see. And this information is very helpful, right? It's not very helpful or informative. I mean, usually you should override the toString method so that it returns a digestible string representations. Like normally when I do toString, I have to actually write out, override the toString of the object class and pretty much just write out the information that I want to return. Like circle, its radius, and the counts. So when I run the method to call toString, it's return the actual information out. And this is more informative, right? Like the circle itself right here from toString. If I don't have toString, let's see if I commenting this out. That output is not going to be like that. It's going to be the default toString form. The object class, which is going to return, see, the name of the class, the package, and the name circle, and its ID of the instance, which is not informative at all, right? So that's why we like to overwrite like that. Overwrite. If you want to use annotation override, it's fine too. To make sure you override the toString of the object and have the informative information printing out, which is the radius and the count of the circle, depending on your program. Alright, next topic we're going to cover is polymorphism. So it's going to be on the next videos.